Hi there, and welcome to Unit 4 Opener number 11. We're going to continue looking at solving some quadratic and absolute value equations. So taking a look at this first equation, you'll notice that this entire left side is being divided by 6. So this certainly isn't the only way to solve this, but I think the easiest way is to start by multiplying both sides by 6 in order to get rid of this denominator here. As we discussed in some of the previous videos, 8, 9, and 10, our goal is going to be to get this part, the squared quantity, in this case 3x minus 5, we're going to be trying to isolate that part, and then we'll square root both sides, and then we'll solve from there. So the goal here is to sort of strip away all of these other parts until the 3x minus 5 squared is by itself. So next I'll just add 2 to both sides, and that'll leave me with 7 times 3x minus 5 squared equals negative 28. Now a lot of people at some point want to try to distribute this 7, but you can't do that because this quantity is being squared and you can't go do this multiplication before this exponent happens. So instead what we're going to do is get rid of the 7. Right now it's 7 times this quantity, so we will use division to undo that multiplication. And now we have the squared quantity by itself. 3x minus 5 squared equals negative 4. Now, if you're paying attention, you already realize there's a problem, although maybe you haven't noticed that yet. But now that the squared thing is by itself, I go ahead and I try to square root this side, and I try to square root this side. And of course, as far as you know, you can't really do the square root of a negative number. Because if you do a positive times a positive, you get a positive. And if you do a negative times a negative, you get a positive. There's no way you can multiply a number times itself and get this negative number, at least not using the real numbers that we all know about. So at this point, I guess you would want to put the brakes on and say, okay, there is no real solution. By the way, if you, again, weren't really paying attention, you might go to your calculator and you might attempt to do the square root of negative 4, and I just want to show you what happens if you try that. Square root of negative 4 is, and my calculator gives me this error that there is a non-real answer. It's worth noting, just as sort of a hint to something that will come up later in your math career, the calculator does not say that there is no answer, it just says that there is a non-real answer. And also, you'll notice I didn't write there's no solution, I wrote there is no real solution. So anyway, that's all we could do with that first problem. Let's take a look at this second one. And again, it's going to be pretty much the same thing here. We're going to be stripping away parts of the equation until we isolate the absolute value part. Alright, so I think we can start by adding 4 to both sides. So we've got equals 16 here. Now, this is multiplying by negative 2/5. And the way you undo multiplication by a fraction, at least one of the easier ways to think about it, I think, is to multiply both sides of the equation by the reciprocal. So the reciprocal of negative 2/5 is negative 5/2, and I'll multiply the other side by that as well. And the reason this works is the 5 and the 5 cancel, and the 2 and the 2 cancel, and negative times a negative is a positive, so those really cancel. So you're just left with the absolute value of 5x minus 4 here on the left. And let's see, 16 times negative 5/2 is going to be 16 and 2. 16 divided by 2 leaves me with an 8, and then 8 times negative 5 will give me a negative 40. Alright, well, I've got the absolute value by itself, and it's equal to negative 40. And if you're not really paying attention, you just keep going and you say, okay, well, what I learned how to do in some of the earlier openers, like 8, 9, and 10, is I'm going to write two equations, 5x minus 4 equals negative 40, or the opposite of that, 5x minus 4 equals positive 40. And you solve these two equations. So I'll just add 4 to both sides, and I get 5x equals negative 36, and divide by 5, and divide by 5, and I get x equals negative 36 fifths. Or add 4 on both sides, I get 5x equals 44, divide by 5, and I get x equals 44 fifths. And you say to yourself, oh great, I did the problem and I got the two answers and I'm right. But you actually did not. And let me quickly show you, first of all, that in fact these answers don't work. So I'm just going to substitute, I guess I'll just use the first answer here, negative 36 fifths, and I'll substitute that back in the original equation. And I'm going to see if I really get 12 as the answer. So let me try. Negative 2 fifths times the absolute value of 5x minus 4 minus 4. So, if in fact, oh, sorry, I can't put x there. I need to put negative 36 fifths there. Negative 36 fifths. Okay. Alright, so let's try this again. I've got negative 2 fifths times the absolute value of 5 times negative 36 fifths minus 4. I guess I do want that last parenthesis there. And then this second minus 4 at the end. Alright, in any case, when I hit enter, I'm supposed to get 12. But I don't. I get negative 20. Well, why is that? So first, in terms of vocabulary, it's worth noting that, in fact, this thing that claims to be a solution but is not, and if you tried 44 fifths, you'd have the same issue. This is called an extraneous solution. And essentially what that means is I did all the algebra right, yet for some reason it gives me an answer, and that answer is not actually a solution to the equation. And here's why. If you go back and you look at this step right here, you'll notice there's something very, very wrong happening here. There's no way that you can do the absolute value of something. I don't care if it's 5x minus 4. There's no way that you can do the absolute value of anything and end up with negative 40 as your answer. So anytime that you have isolated the absolute value and it's supposed to equal a negative number, you actually know right away that there will be no real solution. So if you're paying attention, you know that there's no real solution. If you're not paying attention, unfortunately, when you do all this work and you get these two answers, what you're going to have to do is go back and check and make sure they really do work. Otherwise, you'll feel real good with what you believe to be the correct answer on your paper when in fact it's not. So these were two different examples of equations that did not have a solution. In the quadratic, it's fairly easy to see that it didn't have a solution because you can't square root a negative number, at least not using real numbers. And in the second one, the absolute value equation, it's a little bit harder to see that there's no solution because you do in fact come up with these two extraneous solutions which you either need to go back and check to see whether or not they work, or better yet, just pay attention as you solve the equation and notice that you ended up with something illegal. All right.